right, this video is going to be really short because there's not any examples on the slides. We're going to do those as warm-ups tomorrow. So you're mainly going to just write down the theorems and their equations that go along with them. So, and there's just a couple of them. So 10.5, we're talking about segments. So we're kind of moving away from angles and the measures of arcs, and we're moving to talking about the actual lengths of the segments that are found in our circles. So first one up is theorem 1015. We still have two chords here that are intersecting inside the circle, so this should look familiar. But instead of looking at the arcs BD and CA, we're just looking at the segments. So we're looking at BA, CD, EB, EA, CE, and ED. Okay, so hopefully you can see all of those, within the picture. All right, so what we're going to do here is we're going to take the product of the lengths of the segments of one chord, and then that's going to be equal to the product of the lengths of the other two chords. So we see that CD is our one chord and BA is our second chord, and you see that E is the point that they intersect at. So we're going to take BE times EA, and then that's equal to CE times ED. Okay, that's all we're going to do. We're just going to multiply those together. Okay, so hopefully that makes sense. So make sure you write that down and make sure you get this equation at, lost my cursor, there we go. This equation at the bottom here, please make sure you write that down. Okay, so 1016 is a little different in terms of making sure you see the different tangents and secants. So there's kind of a lot on this slide. Just make sure you pause it and write everything down. So we know what secants and tangents are, and we saw some theorems in 10.4 that talked about the differences of the arcs and finding the angles. Well, those pictures are going to look the same. So we're going to still have a tangent segment. That's the segment, though, that is tangent to the circle at an endpoint. Okay, so it's still really intersecting the circle only once, and then it has this one endpoint on the circle. Secant, and then it's basically still going to be the same thing as a secant line, to where you are still hitting the circle twice, but it's going to look a little different in terms of a segment. So I'll show you a picture in just a second, but just remember, tangent, it's hitting once, secant, it's still hitting twice. Now, with the secant portion, you're going to have a portion that's inside the circle and that's outside the circle. So the external tangent is the one that's on the outside. So hopefully that makes sense, external, outside. So here's your picture. We have the tangent segment, so you see that its endpoint is still one point on the circle. The whole secant segment is still the line that's intersecting the circle twice. And then the external secant is the one it's part of the secant, but it's the part that's outside. Okay, so hopefully that makes sense. So please make sure you label all of those parts, and what might help is to color code if you have some colors at home. Okay, so here's the theorem 1016. If you look here, we actually have two different secants here. We have EB and ED, okay, which breaks it up into EA, AB, EC, CD. So then what this theorem says is you're going to take the product of EA times EB, and then that's going to be equal to EC times ED. So what I want you to do is, knowing this stuff here that you just wrote down from that previous slide, and now you know what this picture looks like with two secants, and you know this equation with the product of two different things, I want you to try to write this theorem out. So again, you're looking at EA times EB, and you should know what both of those are, and then is equal to EC times ED, and again, you should know what those are. So hopefully you can write out, in terms of this vocabulary, what theorem 1016 is all about. And we'll definitely talk about this tomorrow. So if you're kind of confused, don't worry too much, just try to get something down on your paper, okay? And then the last one. So you have your tangent segment, EA, and you have the secant, ED, and this C should be right here intersecting. It just didn't copy correctly. but that should be where this is intersecting the circle at C. All right, so then this guy says, if I take EA and I square it, that's going to be equal to EC times ED. Okay, so again, from this previous slide, you should know what these different segments are. So I want you to try to put that theorem in your own words using the idea of EA squared is equal to EC times ED. Okay, so try to summarize it just in your own words. Okay, so tomorrow we'll have some warm-ups that use these theorems in examples. So you don't have any examples to write down tonight. That's going to come tomorrow for your warm-up. And then we will definitely go over these last two theorems and summarizing them in your own words, and then move forward with some more problems. See you guys.